The scenario described involves a GFCI receptacle with a standard receptacle downstream. A GFCI tester indicates correct wiring via its test lights at both locations. However, the test button on the tester fails to trip the GFCI, whether used at the GFCI receptacle itself or at the downstream standard receptacle. The test button on the GFCI receptacle does trip the GFCI and cuts power to the downstream receptacle. Firstly, let's address the possibility of a faulty tester. Even if the tester functions correctly on other GFCIs, it doesn't guarantee its accuracy in every situation. Testers can develop intermittent faults or be sensitive to specific wiring configurations. Secondly, consider the possibility of a wiring issue that the tester cannot detect. Several scenarios could explain this. One possibility is that the GFCI receptacle itself is not wired correctly. Even if the test lights indicate proper wiring, there could be subtle errors in the connections. Another potential issue is that the standard receptacle downstream is wired incorrectly. This could interfere with the GFCI's ability to trip when tested from that location. A loose connection somewhere in the circuit is another possible culprit. Loose connections can cause erratic behavior and may not be consistently detected by a simple tester. Finally, there could be a ground fault somewhere in the circuit. A ground fault occurs when current leaks from a hot wire to ground, but the leakage may not be sufficient to trip the GFCI under normal conditions or be detectable by the GFCI tester. To troubleshoot the issue, begin by replacing the GFCI receptacle. This eliminates the possibility of a faulty GFCI as the source of the problem. Next, replace the standard receptacle downstream. This ensures that the receptacle itself is not contributing to the issue. Carefully check all connections in the circuit for looseness. This includes the connections at the GFCI receptacle, the standard receptacle, and any junction boxes along the circuit. Ensure that all wires are securely fastened and that there are no loose strands. Use a multimeter to check for a ground fault. Set the multimeter to measure resistance, typically in the megohms range. Disconnect the circuit from the power source at the breaker. Then, measure the resistance between the hot wire and ground and between the neutral wire and ground. A low resistance reading, such as less than 1 megohm, indicates a potential ground fault. Further investigation would be needed to pinpoint the exact location of the fault. If the resistance reading is very high, then that is a good sign that there is no ground fault. Regarding ground fault testing, you would want to make sure that the circuit is de-energized first. If you were to test a live circuit for ground fault, you will possibly damage the meter or get an inaccurate reading. If you are unsure of testing resistance on a multimeter, consult the manufacturer's instructions for guidance. When checking connections, it is important to ensure that the wire gauge is appropriate for the circuit breaker size. For example, a 15 amp circuit typically requires 14 gauge wire, while a 20 amp circuit requires 12 gauge wire. Using undersized wire can lead to overheating and potentially a fire hazard. Refer to the National Electrical Code, NEC, Table 310.15 B16 for allowable opacities of insulated conductors. Make sure that the connections are properly tightened. Over-tightening can damage the wires or the receptacle, while under-tightening can lead to loose connections. Use a Torx screwdriver to ensure that the connections are tightened to the manufacturer's specifications. If you find any damaged wires, replace them immediately. Damaged wires can be a fire hazard. Also, make sure to use the correct type of wire connectors. Wire connectors are designed to securely join wires together. Using the wrong type of wire connector can lead to loose connections. When working with electrical circuits, it is always important to take safety precautions. Wear safety glasses and gloves to protect yourself from electrical shock. Always turn off the power to the circuit before working on it. If you are not comfortable working with electricity, it is best to call a qualified electrician. If the GFCI trips immediately when you try to reset it, there is likely a ground fault or a neutral fault. A ground fault occurs when current flows from a hot wire to ground. A neutral fault occurs when current flows from a neutral wire to ground. To find a ground fault or neutral fault, you will need to use a multimeter or a ground fault locator. If the GFCI trips intermittently, the problem may be a loose connection or a faulty appliance. Check all of the connections in the circuit to make sure that they're tight. You can also try plugging different appliances into the circuit to see if one of them is causing the GFCI to trip. If you have tried all of these steps and the GFCI is still tripping, you may need to call a qualified electrician to help you troubleshoot the problem. Electrical work can be dangerous, so it is important to take precautions when working with electricity. Always turn off the power to the circuit before working on it. Wear safety glasses and gloves to protect yourself from electrical shock. If you are not comfortable working with electricity, it is best to call a qualified electrician. When inspecting the wiring, pay close attention to the neutral wire. The neutral wire carries the return current from the circuit back to the electrical panel. If the neutral wire is not properly connected, it can cause the GFCI to trip. Also, make sure that the neutral wire is not connected to the ground wire. This can also cause the GFCI to trip. The neutral and ground wires should only be connected to the electrical panel. When checking the connections, use a wire stripper to remove the insulation from the wires. Make sure that you do not damage the wires when you are stripping the insulation. Also, make sure that you use the correct size wire stripper for the size of the wire. After you have stripped the insulation from the wires, twist the wires together tightly. Then screw on a wire connector. Make sure that the wire connector is the correct size for the number of wires that you are connecting. When you are tightening the wire connector, make sure that you do not over-tighten it. Over-tightening the wire connector can damage the wires. If you are not sure how to tighten the wire connector, consult the instructions that came with the wire connector. When replacing a receptacle, make sure that you use the correct type of receptacle. There are different types of receptacles for different types of circuits. For example, there are 15 amp receptacles, 20 amp receptacles, and GFCI receptacles. Make sure that you use the correct type of receptacle for the circuit that you are working on. When installing a receptacle, make sure that you follow the instructions that came with the receptacle. If you're not sure how to install a receptacle, consult a qualified electrician. When working with electrical circuits, it is important to be aware of the different types of electrical hazards. Electrical hazards can cause serious injuries or even death. Some common electrical hazards include electrical shock, electrical burns, and electrical fires. To avoid electrical hazards, it is important to take precautions when working with electricity. Always turn off the power to the circuit before working on it. Wear safety glasses and gloves to protect yourself from electrical shock. If you are not comfortable working with electricity, it is best to call a qualified electrician. Remember that ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. GFCIs work by monitoring the current flowing through a circuit. If the GFCI detects a difference of as little as 5 mA between the current flowing into the circuit and the current flowing out of the circuit, it will trip the circuit. This can happen if someone touches a live wire or if there is a ground fault in the circuit. GFCIs are required in bathrooms, kitchens, and other areas where there is a risk of electrical shock. If you have any questions about GFCIs, consult a qualified electrician. If you encounter a situation where a GFCI receptacle trips frequently or unexpectedly, it is essential to investigate the underlying cause rather than simply resetting the device repeatedly. Repeated tripping indicates a potential problem that needs to be addressed. Firstly, consider the possibility of moisture intrusion. GFCIs are particularly sensitive to moisture, and even small amounts of water or condensation can cause them to trip. Check for any signs of leaks or dampness around the receptacle, especially in bathrooms or kitchens where water is commonly present. Secondly, evaluate the appliances connected to the circuit. Faulty appliances can introduce leakage current that triggers the GFCI. Disconnect appliances one by one to see if the tripping stops. If a particular appliance is identified as the cause, have it inspected and repaired or replaced. Thirdly, examine the wiring connections within the receptacle box. Loose or corroded connections can create resistance and lead to voltage fluctuations, which may cause the GFCI to trip. Tighten any loose connections and clean corroded ones. Fourthly, consider the age and condition of the GFCI receptacle itself. Over time, GFCIs can degrade and become more prone to nuisance tripping. Replacing an old GFCI with a new one can often resolve the issue. Fifthly, investigate the possibility of shared neutral connections. If the circuit shares a neutral wire with another circuit, imbalances in the current flow can cause the GFCI to trip. Separate the neutral wires to see if this resolves the problem. Sixthly, check for any sources of electromagnetic interference or EMI. EMI from nearby electronic devices can sometimes interfere with the operation of GFCIs. Move any potential sources of EMI away from the GFCI to see if this makes a difference. Seventhly, consider the load in the circuit. Overloading the circuit can cause the GFCI to trip. Reduce the number of appliances connected to the circuit to see if this resolves the problem. Eighthly, inspect the wiring insulation for damage. Damaged insulation can create a path for current leakage, leading to GFCI tripping. Replace any damaged wiring. Ninthly, check for the presence of any hidden ground faults. Even small ground faults that are not readily apparent can cause GFCIs to trip. Use a ground fault locator to identify and isolate any hidden ground faults. Tenthly, if all other troubleshooting steps fail, consult a qualified electrician. An electrician can perform a more thorough inspection of the circuit and identify any underlying problems that may be causing the GFCI to trip. Remember, safety is paramount when working with electricity. If you are not comfortable performing any of these troubleshooting steps, it is best to call a qualified electrician. In addition to these troubleshooting steps, it is also important to understand the limitations of GFCI testers. GFCI testers are designed to simulate a ground fault and verify that the GFCI will trip within a specified time. However, they do not test all aspects of the GFCI's operation. For example, they do not test the GFCI's ability to detect small leakage currents or to protect against neutral to ground faults. Therefore, it is important to not rely solely on a GFCI tester to verify the proper operation of a GFCI. Regular visual inspections and periodic testing with the GFCI's test button are also important. Furthermore, it is crucial to understand the difference between a GFCI receptacle and a standard receptacle. A GFCI receptacle provides ground fault protection, while a standard receptacle does not. GFCI receptacles are typically installed in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Standard receptacles are typically installed in areas where there is not a significant risk of electrical shock. When replacing a receptacle, it is important to use the correct type of receptacle for the application. Using a standard receptacle in an area where a GFCI receptacle is required can create a safety hazard. Finally, it is important to be aware of the electrical codes in your area. Electrical codes are designed to ensure the safety of electrical installations. Consult the NEC and local electrical codes for specific requirements related to GFCIs and other electrical devices. By following these troubleshooting steps and understanding the principles of GFCI operation, you can effectively diagnose and resolve GFCI tripping problems. Remember to prioritize safety and consult a qualified electrician if you are not comfortable working with electricity. If the voltage is 120 volts, the current required to trip a GFCI is typically between 4 and 6 milliamps. The response time for a GFCI to trip is typically between 0.25 and 0.4 seconds. These values are based on Underwriters Laboratories ALL Standard 943. A GFCI tester typically applies a load to the circuit that simulates a ground fault. The load is typically around 30 milliamps. If the GFCI trips within the specified time, the tester will indicate that the GFCI is working properly. If the GFCI does not trip, the tester will indicate that the GFCI is not working properly. However, as mentioned earlier, the tester does not test all aspects of the GFCI's operation. A multimeter can be used to check the voltage, current, and resistance of an electrical circuit. When checking for a ground fault, you will want to measure the resistance between the hot wire and ground, and between the neutral wire and ground. A low resistance reading indicates a potential ground fault. Always use caution when working with electricity. Turn off the power to the circuit before working on it. Wear safety glasses and gloves to protect yourself from electrical shock. If you are not comfortable working with electricity, it is best to call a qualified electrician. The NEC provides detailed requirements for the installation and use of GFCIs. Refer to the NEC for specific requirements related to GFCIs in different locations.